Hello everyone, respected sir. Myself Tejashri and my roll number is 23401A04B6. I am from ECE B section in SRIT College, Anantapur. So I am looking forward to you explain about the topic of construct and working principle of MI instruments which is from the subject of basic electrical and electronics engineering. The subject code is 23EE101. Introduction of moving iron instruments. Moving iron instruments are a type of electromagnetic instrument used for measuring electrical quantities. They are widely used in industries, laboratories, and power systems for measuring voltage, current, power, and other electrical parameters. These instruments are based on the principle of attraction and repulsion between a fixed coil and a movable iron piece. Construction of moving iron instruments. Moving iron instruments consist of a coil wound on a non-magnetic frame which is fixed in position. A soft iron piece known as the moving iron is mounted on a spindle and can move freely within the coil's magnetic field. The spindle is connected to a pointer which indicates the measured value on a calibrated scale. Here we have a diagram. Observe this closely. Working principle of moving iron instruments. Here, the magnetic field produced by the coil interacts with the magnetic field of the moving iron, causing it to move towards or away from the coil. The extent of movement of the iron piece depends on the magnitude of the current or voltage being measured. Types of moving iron instruments. There are two main types of moving iron instruments: attraction type and repulsion type. In the attraction type, the iron piece moves towards the coil when current flows through it. In the repulsion type, the iron piece moves away from the coil when current flows through it. Construction of attraction type moving iron instruments. In attraction type instruments, the coil is wound on a soft iron core which produces a strong magnetic field when current flows through it. The moving iron piece is attracted towards the coil due to the magnetic field interaction. The deflection of the iron piece is proportional to the current passing through the coil. Construction of repulsion type moving iron instruments. In repulsion type instruments, two identical coils are wound on the same core and connected in series. When current flows through the coils, the magnetic fields repel each other, causing the iron piece to move away from the coils. The deflection of the iron piece is proportional to the square of the current passing through the coils. Advantages of moving iron instruments. Moving iron instruments have a wide measurement range and can measure both AC and DC quantities. They have a simple construction and are relatively inexpensive compared to other types of instruments. These instruments are rugged and can withstand harsh environmental conditions. Limitations of moving iron instruments. Moving iron instruments have a relatively low accuracy compared to other types of instruments, especially at higher frequencies. They have a slower response time and are not suitable for dynamic measurements. The iron piece may experience hysteresis and residual magnetism, leading to measurement errors. Applications of moving iron instruments. Moving iron instruments find applications in power systems for measuring voltage, current, and power. They are used in laboratories for research and development purposes. These instruments are also used in industries for monitoring and controlling electrical parameters. Conclusion. Moving iron instruments are electromagnetic instruments widely used for measuring electrical quantities. They work based on the principle of attraction and repulsion between a fixed coil and a movable iron piece. Despite their limitations, they are popular due to their wide measurement range and rugged construction. Thank you. Thank you for giving this opportunity.